Hey, physics friends. I wanted to give you a little bit of another go-round of how to create these graphs, how to go from a position versus time graph down to a velocity versus time graph, and then how to go from a velocity versus time graph down to an acceleration versus time graph, and vice versa. How do you go up the ladder from acceleration to velocity, velocity to position? So I'm going to be a little bit more specific. I'm going to do a bunch of examples to tie everything I went through in the last lesson together, just so you can kind of see this come together one more time. And so I wrote down some like different things that I do when I'm going through this. So if you want to write these down too to kind of give yourself some directions on how to do this, you're more than welcome to do that. So first of all, I'm going to talk about going down, meaning going from position to velocity and then going from velocity to acceleration. And they're always going to be in that order: position, velocity, acceleration. So number one, the first thing I'm going to do is find the slope at every point. And I mean every point. I've got a couple of examples here. Sometimes every point they have the same slope, and sometimes every point the slope is changing. So for instance, in this very first one up here, the slope at every point along the first second, these slopes are all 0. So the slopes at every point there, that's equal to 0. The slope at every point here, that slope is always -8. And the slope at every point here is the same. These are all like straight lines, so the slope at every single point is always the same. So this slope is going to be 4/3 or 1.3 repeating. 1.3-ish. So then what you do, what I wrote on my instructions, the slope at every point is what the graph below reads. So plot those points. So go back here. The slope is what this graph reads. So since the slopes at all these points are 0, this is what my velocity is. I'm standing still. That's what that position versus time graph means. And then, make that -8. The slope at every one of these points is -8. That's my velocity. And then, my slope at every one of these points is 1.3. And I'll do the exact same thing when I go from this graph to this graph. The slope here at all these points are 0, 0, 0. So this means that I'm not accelerating. I'm going at a constant speed, constant speed, constant speed, right? So what does it look like if it's not straight lines? You know, how do you handle that? I'll give you another example of something that's got a curved line to it. So let's see if I can just scroll down. Here's one with a curved line. So kind of following my standard operating procedure, I find the slope at every single point. Every single point in the first 4 seconds, the slope is 0. Every single point in the last 2 seconds, that slope is also 0. It gets tricky in the middle here. The slope at every single point is changing. At the beginning, my slope is equal to 0. It's horizontal, so that slope is equal to 0. At the end, I actually have a slope. So I'm just going to draw in a tangent. Now, again, you draw a line in, and there's a little bit of subjectivity to this. When you get to calculus, there's a way to then actually find that, and that's beyond what I'm requiring for you in high school. But if you're going to go on in this, it's just calculus. It's called the derivative, and you'd be able to find this exactly. But for right now, you just draw a tangent line, and you find the slope of that point. So this looks like the slope is 5, 10, 15 over 2. So this slope looks like 7.5. Right, so now I found the slope at all the points, and then I'm sure that this is somewhere in between, but really I just need to find the beginning and find the end, and I'm going to connect the dots. So the slope at all these points are equal to 0. The slope at this point is equal to 0, and the slope at this ending point is 7.5. So again, I'm going to change my axes, and I'm going to run it here to 7.5. And it goes like that. My velocity is increasing. And then my velocity is equal to 0. Again, finding my slopes one more time. The slope at all these points are equal to 0, so that's what your acceleration versus time is. The slope here, it goes up 7.5 and then over, what is that, 4? So 7.5 over 4 is like boy, I don't know that I've got to use my calculator here to do that one. And that's 1.9, so it's a positive. So I go up here to like 2-ish, and then my slope is 0. So that's how you go, kind of in a nutshell, from when you're going down. You're finding the slope at every single point. Sometimes all these points are the same slopes. Sometimes all these points have different slopes. Now, the next thing, how do you go up the ladder? How do you go from, okay, a couple of points. In high school, your velocity is never going to have a curved line to it. It's only ever going to be a diagonal or a horizontal line, because that represents, if your velocity is curving, that means that your acceleration is accelerating, and that they call that the jerk, actually. So don't worry about any of that stuff. So you're never going to have a curved line in the velocity versus time graph. And then inside of the acceleration, it's only ever going to be horizontal. You're never going to have a diagonal one. That's beyond high school physics when your acceleration is accelerating, you know. Now, going up the graph. When you go from an acceleration versus time up to velocity, or if you go from velocity up to your position versus time, the first thing that you're going to do, I like to draw a horizontal line at 0. And let me show you what I mean. So I'm going to go back here. Let's do this one right here. I'm going to draw a horizontal line right at 0. And again, I'm going up the graph here. Second thing I do, I find the areas between that line and the curve. So if I go above that, that's a positive area. And if I go below it, it's a negative area. That's really important. Use colors if possible. And I like to use red and blue because I have a smart board and I've got markers. So this area is a positive area. So I'm just going to draw this, and this is a triangle. And this area right here is also a positive area. So it's going to be another triangle. So the area of this first section, this area equals 0. The area of this second section, it's base times height divided by 2. So I go to the base, which is 2, the height, which is, it looks like 3. I gotta get, yep, it's 3. So 3 times 2 is 6, so half of that is 3. So this area is positive 3. Same with this one, because it looks like the same shape. And then this area over here is equal to 0. That area represents how much the graph above it changes. It represents how much the graph above it changes. So I'm going to put some dots on my graph. Start at 0 if you can. Put the dots at the distinct times according to how much it changes. So here's what I mean by that. I'm going to start at 0 if I can. You can start these graphs wherever you want. So this represents how much it changes. It changes 0. And then it changes positive 3, so I'm up here at 3. And then it changes another positive 3, so I'm up here at 6. And then it changes 0, so it ends at 6. So these are my dots that represent how much the position changes. Lastly, I'm going to connect the dots. If it's a positive slope, then you have concave up. And if you have a negative slope, it's concave down. I used happy face and sad face. Concave up is happy. Concave down is also known as sad. I wanted you to see these two terms because you're going to see them in math as you go on in pre-calc. Concave up and concave down, we call that concavity, and I'll show you what I mean over here. So I jump over, and this is, I'm going to connect these dots, horizontal line, and this is a positive slope, so it's concave up. This is a negative slope, so it's concave down, and then a line like that. Let's do one more. And then I'm finished with this guy. I'll go back to this one up here. Whoops, not this far. Right here, this guy right there. So again, step 1, draw my line at 0. Step 2, find my areas. This is a negative area. This is going to be a positive area, 2 triangles. Here's a rectangle. That's going to be a positive area. And then I have no area at the end. So at the beginning, it's 2 times 1, half of that. So this area is a negative 1. This area looks like 2 times 4. So that's a positive 4, that area. This area is 4 times 1, so that's also a positive 4. And then this area right here is equal to 0. So I start at 0 if I can, if it's going to fit on my graph. And then I change -1. So at this time, I'm down here at -1. And then I'm going to change positive 4. So then I change up to 3. Notice that there's a difference. Like, this represents the change. I don't go up to 4. I go down to 3 because that's how much it changes. Common mistake that I see a lot of times. So this is at 3. Then I change another 4, so I'm up here at 7. And then I change 0, so I stay here at 7. Now I connect my lines with my concavity. This is a positive slope, so it's concave up, or a happy face. Another positive slope, so it's also a happy face, or concave up. Diagonal line, constant velocity, constant velocity. So hopefully you saw me do a couple of these things here. You got a few techniques to help you in the future as you're going through this. If you have more questions, the best thing that you can do is to work with a friend that you can both be bouncing these ideas off. Hey, you forgot this. Oh, remember, you're not going up to 4. You're changing 4, right? So have a good day. And again, I'm going to skip over going from this graph to this graph because it's just slopes. So I find the slope, find the slope, find the slope. I did that before, just kind of in the essence of time. So have a great day. Stay positive. Keep trying these. Keep working with your friends. You'll catch it eventually. Keep working.